Hello everyone, in this video we are going to make a BCD counter and also show the result on the 7 segment, and also we will make a practical demo of that. So as you could see here, we use 74LS90, which is the BCD counter with actually seeing each clock pulse. These BCD counter able to count from 0 to 9. So, and should be back to the 0 because this is a BCD counter. So you see the result here. The BCD code should be the output. So that means from the clock, which is these counter works based on the falling age clock. That means whenever it's C changing from 1 to 0 in this clock, which is the falling age, it start to count. So first falling age 0, next falling age 1, next 2, 3, end up with the 9, and you see the BCD codes here on the output. But we don't want to see the BCD codes. We want to somehow convert that BCD to the 7 segment and see the result that counting in the 7 segment. That's the reason we connect the output of that to 74LS47, which is one BCD to 7 segment code converter, and see the result on the 7 segment. So if you are not familiar with the BCD to 7 segment code converter, please watch our previous video, which is the BCD to 7 segment code converter, and we explained this part of the circuit. So as you could see here, this is the circuit diagram. So for 74LS90, so you have the pin 14 as a first clock, which is you use this circuit like this. So you connect to this 0. So whenever this switch is closed, you have 5 volt on these clock pins. So whenever you open that, so you somehow disconnect from this source and you have the 0 over there. So that means if this is sensitive for the falling age, right now it is 1. So whenever I open that, I change that to the 0. So that means it should be sensitive to the opening of this switch. Whenever I open that, should be start to counting. I will show that later on. So we have few pins here, 2, 3, 6, 7, 10, which we just deactivate them with the 0. So these pin 12, 9, 8, 11 is the BCD output, and the 5 is the VCC. So we connect that to the input of the one BCD to 7 segment that we able to see the result on our 7 segment. So let's start to do that. So right now this is the 1, so that means we give the clock is 1, and it is sensitive for the falling age. So that means whenever I open that, somehow this change from 1 to the 0, which is the falling, it should be start to the count. So let I open this. I open that, it's changed to the 1, right? So see, whenever I'm again close that, nothing happened because this is the sensitive to the falling age. Whenever you are in the open position, that means this is the 0, you change 0 to 1, which is the rising age. So this is not sensitive to the rising age, this is sensitive to the falling age. You see this a circle with this triangle, it says this is this clock of this BCD counter is sensitive to the falling age. So that means whenever you open this switch, it's actually start to count. So let's open that again, it should be changed to the 2. So close, open again, so see it is 3. So as you could see, whenever I open that, it's actually changed because this counter is sensitive to the falling age. So again, the next is 4, so the next it should be 5, so the next should be 6, so the next should be 7, the next should be 8, so the next should be 9. And just be careful, this is a BCD counter. So in the BCD we just have 0 to 9. After 9 it should be back again to the 0. So currently I'm in 9. If you see another falling age, it's actually back to the 0. And you could actually continue to count, so which is it's able to read the falling edge of your clock, and whenever see the falling edge, start to count that edge. So right now I'm on 5, 6, 7, 8, and finally 9, and back to the 0. So this is simulation. Let to implement the same circuit on the breadboard and see the practical demo works or not. So this is a BCD counter. So as you expect, the BCD counter should be start to count from the 0 to 9 and again back to the 0. So here we use 74LS90, which is the BCD counter, and we connect the output of the BCD counter to code converter. This is 74LS47, so which is the BCD to 7 segment code converter. So that means here we count from 0 to 9 BCD. Then we have this code converter, which is convert the BCD to 7 segment, and we are able to see the 7 segment code here on the 7 segment. Okay, so this is our BCD counter is sensitive to the falling edge, so we are connected to clock pulse of these counter to the switch. Whenever we push the switch, it's actually get 1. Whenever we release, it's actually move from 1 to 0. This is sensitive to the falling edge. That means whenever you push the switch, it got 1. Whenever you release, it get the 0. So that means whenever it's C1 to 0, it is the counter start to count. So we have the bouncing switch problem. So definitely sometimes whenever you push and release, it is possible it's count more than 1, which is that's fine, because in the bouncing switch means whenever you push and release the switch until the switch get its stable condition, usually it jump around 0 and 1. So same thing whenever you release that. If you want to release it, move to the 1 to 0 until it gets the stable condition. It's actually jump around 0 and 1. So that's the reason whenever you push the switch, sometimes maybe you see it's actually count more than 1, which is the reason of that is the bouncing switch. Here we use one small resistor circuit, which is somehow to fix the problem, but it's sometimes happen even you have the circuit here. Okay, so let us start to counting with pushing this switch. So we are on the 0, I push the switch, I release, it's actually get 1 and 2, which is that means because of the bouncing switch, it's actually get 2 pulse. That's the reason it's actually go to the 2. So again, release that 3, release the switch 4, release 5, 6, 7, again bouncing switch, it's actually count 3. So next should be 8, next is again it's actually count 9, 1 and 2 very fast because of the bouncing switch. So let's try again from 2, 3, 4, 5, 6, 7, 8. It's again bouncing switch. It's actually count 2, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, 1. So as you could see, it works. So even if it's actually count very fast, the reason is this bouncing switch. So I'm doing that again, just try our chance and see if we could count and see all that numbers. So start with the 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4. So as you could see, it works. So this shows how you could use the BCD counter and show the result on the 7 segment.